Yes, sir. Just give me a minute. The answer D है.
ठीक है, okay. D is fine. There are 5. Now point out which 5 experiments. Name them.
Experiment 1, experiment 4, experiment 5, experiment 7, experiment 8.
Wait a second. I really don't get it. Explain me experiment 1.
I'm a little unsure about experiment 1. Baki 4, 5, 7, 8.
Okay, explain me experiment 5.
Experiment 5. No, not experiment 5. Wait.
Yeah.
Okay. Displacement reaction.
Yes, it is. Now, if you look at the chapter in the book, do you have the book in front of you?
Yes, sir.
If you look at the chapter in the book, there is a diagram with a big test tube in about the 3rd or 4th page of the chapter. Not the page number exactly, but the 3rd or 4th page of the chapter shows you a big test tube diagram having 2 immiscible layers. The bottom one is colorless, and that is a water layer. The upper one is actually a hexane layer, which is tinted with iodine, and that shows you a purple layer, right?
Yes, sir.
Now,
Yes.
if you mix hexane and iodine, that gives you a purple layer. Now, the book clearly tells you that, right? So
Yes,
take the
sir.
hint and work out the experiment numbers which will have iodine in them, even after the complete displacement, after or before, whatever the case may be. So which 5 experiments out of these 9, which 5 are going to have a purple layer on top?
3 and 6.
Okay, what else? There are 5, so there must be 3 more.
Red layer. 3, 5.
No, it can't be experiment 5.
No, not experiment 5. 3 and 6, sorry.
3 and 6. Okay, what else?
3 and then 4 and 7.
How can it be 4?
No, it's more reactive.
It's not a matter of more or less reactive. It does not even consist of iodine.
iodine के साथ सिर्फ.
Yeah, only iodine shows purple color.
So 3, 6, 7, 8, 9.
Right, now you're good. Now, if I point it out and I'm going to use a different color, now notice this says iodide ions, so there must be some iodine in here. Whether the displacement occurs or not, that's not the point, but the iodine must be there, whether in the form of iodide ions or iodine itself. Now, if we notice about this, we have iodine in here. So whether the displacement occurs in these experiments or not, that's not the point exactly. The point is there must be some iodine in these 5 experiments to have an upper layer with the purple tint. So this gives you D. Now, let's discuss, as per our understanding, whether the displacement would occur or not. So yeah, the displacement would occur in this one. Yeah, definitely would be done in this one. There would be no displacement over here, no displacement over here. This is a reaction between iodine and iodide. Of course, there is going to be no displacement over here. This is not even an experiment for displacement. So these will produce iodine as a product. This would have iodine as an unreacted reactant, and this would have iodine because there can't be even a reaction in there. So actually all 5 of these consist of iodine, which would easily mix into hexane, and once it mixes into hexane, then we clearly understand that this is going to give us a purple color. Make sense?
Yes, sir.
Good. Walaikum assalam. But we have already answered the question, and as you can see the hints in there, I hope you get the idea that which 5 experiments have iodine. Since you answered that day and your answer was correct back that day, so I hope that you would easily be able to come up with these 5, right? If you still have a question, go ahead.
No, sir.
Okay, great. Okay, let's move on. Let's go with this one.
Sure.
We need a revision. Yeah, you were about to say something?
Yes, sir. I was saying, can we do paper 2 today?
Yeah, sure. For the same chapter?
Yeah.
Okay, sure, no problem. Just let me stop sharing.
Sodium halide salts react with concentrated sulfuric acid at room temperature. Write an equation to represent the reaction of sodium chloride with concentrated sulfuric acid. Sodium chloride with concentrated sulfuric acid is equals sodium sulfate plus HCl. Na2SO4 plus HCl.
It should be 2HCl if it's Na2SO4 for a balanced
2HCl.
equation. And yes, the products are correct.
Name this type of reaction. Neutralization.
Not exactly neutralization. You can
As
quote it as acid-base reaction, but I would prefer if you go with a displacement reaction. Now, this is not like a common acid-base question. Neutralization is a reaction which actually gives us a neutral product, water, out of an acid and an alkali. This specific reaction does not produce water. So the word neutralization exactly don't fall under the category. However, they do correct acid-base reaction for this name, but I prefer my students to go with displacement. I hope
yes,
you do
sir.
understand why displacement, because the hydrogen and the sodium are displaced, have displaced their negative ions, and it simply is a double displacement. 2 displacements occurring simultaneously. So simply going with the displacement reaction is going to cut it, right?
Yes, sir.
Moving on with B.
Sodium iodide reacts with concentrated sulfuric acid at room temperatures to form steamy fumes. Identify the chemical responsible for the steamy fumes.
Hydrogen iodide.
Hydrogen iodide, that's perfect.
Yes, hydrogen iodide.
Okay, in any reactions of sodium or potassium salts, halide salts I'm talking about, with concentrated sulfuric acid, the usual semi fumes are because of the HX form. Now, if it was sodium chloride, the HX must be hydrogen chloride. If the sodium, it was sodium bromide, it should be HBr. For sodium iodide, it should be HI. The initial steamy fumes, what they're responsible for, but sometimes there are more products, and that's what we're going to handle in upcoming questions. Moving on to part B, part 2.
The reaction of sodium iodide with concentrated sulfuric acid continues, forming several other products, including a dark gray solid. Identify the chemical responsible for the dark gray solid and one other product of this further reaction. Dark gray solid. Iodine
Perfect. Other product?
and other product. Sodium concentrated. Hydrogen iodide.
Other product, Peter. You just quoted
H2S.
hydrogen iodide. H2S, very good. Can you name other products?
So SO2.
SO2,
Yes.
very good.
What
H2O.
could be
There are many
right?
products that you can write over here.
Lab
SO2,
में ये वो वाला
H2S.
ज़्यादा होते हैं reactions.
Sorry?
I'm telling her that this is the one which has many products.
Yes, exactly. This is the one which has many products. So iodine is just one of them. Apart from HI or I2, we may have SO2 or we may have H2S. There are multiple products. We may have
So
even
we can also
sulfur
have
that we
sulfur,
can
right?
sulfur, right? That is correct. These are all the other products that we may quote. Okay. Number C, part C.
Explain the differences in observations at room temperature when sodium iodide reacts with concentrated sulfuric acid compared to those for sodium chloride. Differences at room temperature. Reactivity decreases down the curve. More um,
So can we tell the smell in observations that hydrogen sulfide has rotten egg smell?
No, he's not asking you about the observations. He's asking you about the differences in observation, and you need to don't not tell them the observations. You need to tell them what the differences, what the explanation for the differences are. आप देखिए HCl वाले में आप नोटिस करें कर क्या रहा है. वो कहता है कि NaCl वाले में हमारे पास स्टीमी फ्यूम्स बने थे सर. NaI में आपने मुझे 5 डिफरेंट प्रोडक्ट्स बता दिए. ऑब्जर्वेशन दोनों की डिफरेंट हो गई. वो कहता है एक्सप्लेन करें डिफरेंट होती क्यों है. NaI के रिएक्ट करने पे आप और प्रोडक्ट्स बताते हैं. NaCl पे आप और प्रोडक्ट्स बताते हैं. NaCl पे आप प्रोडक्ट भी टोटल 2 बताते हैं. Na पे आप 5 या 6 डिफरेंट प्रोडक्ट्स बता देते हैं. क्यों? So this is a theoretical explanation. This is not an observation comparison. So no, you can't write that.
So Na is a better reducing agent.
Okay.
I mean iodide.
Yeah, that is something better to say. You should stick to iodide ions instead of saying NaI, because NaI is later on converted into HI, and whether it's NaI or whether it's HI, actually iodide ions are the ones that are acting as stronger reducing agents. Okay. What about the next point? Because there are 2 marks, so you have to come up with 2 points at least.
So it is a weaker oxidizing agent than chlorine.
Which one is a weaker oxidizing agent?
The iodide.
Sorry, you just said iodide is a stronger reducing agent. Why are you calling them oxidizing agents at the same time?
The weaker oxidizing agent. Stronger reducing agent means a weaker oxidizing agent, right?
But that would be just a reverse argument. That won't get you 2 marks. Because first one is an argument and the second one is a reverse argument. यू डोंट डू दैट इन पेपर्स। एडवांस पेपर्स में ये बहुत ख्याल रखना है कि एक ही आर्गुमेंट लिखकर उसका रिवर्स नहीं लिखना, दो अलग-अलग नंबर नहीं मिलते। Actually cater them as both as a single argument, नंबर तो नहीं मिलेंगे। Okay, इसे थोड़ा सा अंडरस्टैंड कर लेते हैं। Silence tells me that we must have something as an explanatory part over here. Okay, ध्यान से देखिए और समझें। जब आप रिएक्ट करते हैं NaCl को H2SO4 कॉन्सेंट्रेटेड के साथ, तो हमारे पास प्रोडक्ट जो पहली पहली इक्वेशन में आता है, मैं पूरी इक्वेशन प्रोसीड नहीं कर रहा, हमारे पास NaHSO4 बनता है और हमारे पास HCl बनता है इस केस में। ठीक है, जब आप यही काम NaI के साथ करते हैं H2SO4 के साथ, तो इनिशियल प्रोडक्ट आपके पास बनते हैं NaHSO4 अगेन और उसी तरह से HI। अब HCl में क्लोराइड आयंस जो होते हैं वो इतने अच्छे रिड्यूसिंग एजेंट्स नहीं होते। ये रिड्यूसिंग एजेंट है, इसे हम Ra लिख लेते हैं, और ये आपका ऑक्सीडाइजिंग एजेंट है, इसे हम OA लिख लेते हैं, H2SO4। ये आपस में फर्दर रिएक्ट कर सकते हैं। क्या ये कर सकते हैं? नहीं। क्यों? क्योंकि क्लोराइड आयन एक वीक रिड्यूसिंग एजेंट है और H2SO4 इतना स्ट्रॉन्ग ऑक्सीडाइजिंग एजेंट नहीं है कि Cl नेगेटिव को फर्दर कन्वर्ट कर सके। अब जब इसका कंपैरिजन होता है तो इसमें जो आयोडाइड आयंस हैं वो हमारे पास स्ट्रॉन्ग रिड्यूसिंग एजेंट्स हैं। ठीक है, राइट? तो हम इसे ऐसे कोट कर सकते हैं, ये हमारे पास इनके हिसाब से स्ट्रॉन्ग ऑक्सीडाइजिंग एजेंट बन जाता है। ये इतना स्ट्रॉन्ग ऑक्सीडाइजिंग एजेंट होता है कि ये फर्दर I नेगेटिव को रिड्यूस कर देता है I2 में, और ये इतने स्ट्रॉन्ग रिड्यूसिंग एजेंट्स हैं कि ये H2SO4, जिसमें मैंने आपको स्पेसिफिकली बताया था कि S की स्टेट +6 होती है, उसे उठा के कन्वर्ट करता है पहले SO2 में, उससे इसकी स्टेट +6 से +4 में आती है, उसे उठा के कन्वर्ट करता है इसे S में, उससे इसकी स्टेट आ जाती है 0 में, उसे फर्दर उठा के कन्वर्ट करता है इसे H2S में, जहाँ पर इसकी स्टेट आ जाती है -2 में। तो नोटिस करें कि रिड्यूसिंग एजेंट ऑक्सीडाइजिंग एजेंट को बार-बार रिड्यूस कर रहा है, +6 से रिड्यूस कर रहा है +4 में, +4 से कर रहा है 0 में, 0 से कर रहा है -2 में। उसके अंदर इलेक्ट्रॉन्स ऐड होने की कैपेबिलिटी है, वो इलेक्ट्रॉन्स ऐड कर ही जा रहा है। पहले स्टेप पे उसने कितने इलेक्ट्रॉन ऐड किए? 2 इलेक्ट्रॉन ऐड किए, दूसरे स्टेप पे उसने 4 इलेक्ट्रॉन ऐड किए, उससे अगले स्टेप पे उसने फिर 2 इलेक्ट्रॉन ऐड किए। रिड्यूसिंग एजेंट उससे रिड्यूस कर ही चली जा रहा है। ये काम Cl नेगेटिव नहीं कर सकता। Cl नेगेटिव एक वीक रिड्यूसिंग एजेंट है इस केस के हिसाब से, अगर इन दोनों को कंपेयर किया जाए। तो जब भी ये डिफरेंस ऑफ ऑब्जर्वेशंस आएंगे, तो ऑब्जर्वेशंस हमारे पास बहुत डिफरेंट होती हैं। नोटिस करें, SO2 गैस है, एफर्वेसेंस होगी, या आपके पास सॉलिड है जो बॉटम पे सेटल डाउन करते रहता है, यूजुअली पानी के अंदर डिसॉल्व ही नहीं होता। H2S की हमारे पास एक स्मेल होती है रॉटन एग जैसी, इससे गंदी स्मेल एग्जिस्ट नहीं करती लैब में, ठीक है ना? ये इतनी वॉमिटिंग काइंड सॉर्ट ऑफ स्मेल होती है। तो you need to understand that how this changes because of the reducing agent. At the same time, understand ये एक strong oxidizing agent है। ये Cl नेगेटिव को तो नहीं कर सका ऑक्सीडाइज, लेकिन इसने I नेगेटिव को I2 में ऑक्सीडाइज कर दिया। इसकी फर्दर ऑक्सीडेशन इसके लिए पॉसिबल नहीं है। ठीक है, तो ये यहाँ पर ही खत्म हो जाता है, लेकिन ये एक लंबी सीरीज ऑफ चेंज में जाता है। So we have so many products of this. आई होप अब आपको इसकी ऑब्जर्वेशन समझ आती होंगी इन टर्म्स ऑफ व्हाई वी आर गेटिंग दिस ऑब्जर्वेशन। अब आपको प्रोडक्ट समझ आ रहे होंगे कौन कौन से हैं, और अब आपको इसके बैकग्राउंड में जो ऑक्सीडेशन और रिडक्शन रिएक्शन हो रही है और उसमें एग्जैक्टली हमारे पास जो चेंजेस आ रहे हैं, होप यू अंडरस्टैंड दिस वाज -1 एंड दिस वाज 0। तो ये चेंजेस आपको एग्जैक्टली भी समझ आ रहे होंगे। Now you need to understand these are different levels, what the products are, the reason for the formation of those products, okay? Of course, the reason explaining the oxidizing or reducing agent actions, and finally, the oxidation and reduction states that iodine or maybe bromine or maybe chlorine or maybe sulfur shows in these cases. सारी बात अच्छी तरह समझ आती है? Are we
Yes, sir.
good?
Yes, sir.
Great, great. अब आपको यहाँ पर क्या एक्सप्लेन करना होगा? अगर आप एक्सप्लेन कर सकते हैं, कर देते हैं ऑक्सीडाइजिंग या रिड्यूसिंग एजेंट के हिसाब से, ठीक है? तो बात ठीक हो जाती है। अब यहाँ पर आप ऑक्सीडाइजिंग एजेंट के हिसाब से एक्सप्लेन नहीं कर सकते। क्यों नहीं कर सकते? क्योंकि ऑक्सीडाइजिंग एजेंट दोनों केसेस में सेम रहता है, वो कॉन्सेंट्रेटेड H2SO4 ही है, चाहे आप NaI के साथ रिएक्ट करें चाहे NaCl के साथ रिएक्ट करें। फर्क क्या पड़ रहा है? फर्क पड़ रहा है रिड्यूसिंग एजेंट का, क्योंकि ये वाला रिएक्शन रिड्यूसिंग एजेंट दे रहा है, दिस टाइम आई एम गोइंग टू चेंज द कलर। ये वाला दे रहा है Cl नेगेटिव का रिड्यूसिंग एजेंट, ये दे रहा है हमारे पास I नेगेटिव का रिड्यूसिंग एजेंट। फर्क इनकी वजह से पड़ रहा है। ऑक्सीडाइजिंग एजेंट तो दोनों टाइम में एक जैसा ही था, ठीक है। तो पहला पॉइंट ये होना चाहिए, जिसके हिसाब से मर्जी लिखते हैं आप, ये कह दें कि Cl नेगेटिव वीक रिड्यूसिंग एजेंट है एज कम्पेयर टू I नेगेटिव, या I नेगेटिव स्ट्रॉन्ग रिड्यूसिंग एजेंट है एज कम्पेयर टू Cl नेगेटिव। फिर आपको दूसरे स्टेप पे बताना है कि हुआ क्या है, कि Cl नेगेटिव ऑक्सीडाइज नहीं होता Cl2 में, I नेगेटिव ऑक्सीडाइज हो जाता है I2 में। ये है इस चेंज की रीजन। ये इससे 2 पॉइंट्स आपके पूरे होंगे। Now it's really up to you कि आपका आर्ग्यूमेंट की फेज में एग्जिस्ट करता है या रिवर्स आर्ग्यूमेंट की फेज में एग्जिस्ट करता है, तो वो आपके ऊपर अपने ऊपर है, लेकिन दोनों चेंजेस जरूर बताएंगे फॉर 2 मार्क्स। आई होप दैट कंप्लीटली क्लैरिफाइज इट।
Yes, sir.
गुड गुड, ठीक है। तो if that clarifies it, part D.
Complete the equation for the reaction of bromide ions with excess concentrated sulfuric acid at room temperature. Two Br plus 2H plus H2SO4 gives us Br2 plus SO2 plus 2H2O.
Perfect, that's correct. Okay, moving on. Number 2.
Aqueous bromine reacts with methanoic acid to form hydrogen bromide and carbon dioxide gas. The table shows the oxidation numbers of bromine and carbon in the species involved in this reaction. Identify the oxidizing agent in this reaction. Explain your reasoning with reference to oxidation numbers. Oxidizing agent in this reaction. -1 plus 4. 0 से -1. Reduce. And then carbon is getting oxidized and bromine is getting reduced. Oxidizing agent is the one that reduces others. Oxidizes others, itself is reduced. Say oxidizing agent is the one that oxidizes others, itself is reduced.
Exactly.
Okay. So bromine is oxidizing agent. Explain your reasoning with reference to oxidation numbers. Bromine is acting as an oxidizing agent since it's getting reduced, and oxidation numbers 0 से -1, and then from +2 to +4. The oxidation number of carbon increases from +2 to +4, and for bromine it is reduced 0 से -1.
Perfect answer. Even if you only answer with respect to bromine, कि bromine इसमें oxidizing agent है and continuing it changes from 0 to -1 is good enough. क्योंकि of course oxidizing agent वही होता है जो खुद reduce हो रहा होता है, as you said earlier. ठीक है? Moving on.
Suggest one change you would observe ignoring temperature changes when bromine reacts with methanoic acid. One change you would observe ignoring temperature changes. Reacts with methanoic acid. Can we talk about color changes?
That would be the easiest one to answer with. And yes, that's a very good approach. Go with it.
One change you would observe metanoic acid
So orange to colorless.
from hydrogen bromide.
Yes, you're right. अंडरस्टैंड करें, अगर आप थोड़ा सा पीछे जाएं टेबल पर तो शुरू में Br2 है, ऑफ कोर्स ऑरेंज ब्राउन होगा, और बाद में HBr है तो कलरलेस हो गया। ठीक,
Yes,
इसके
sir.
अलावा बच्चे एक और चीज भी देखते हैं, मींस आई हैव सीन स्टूडेंट आंसरिंग इट इन द टर्म्स ऑफ gas as being a part of products. So effervescence, color change is one good approach, but आपने कोई भी ऑब्जर्वेशन बतानी है, वो आप कार्बन डाइऑक्साइड की effervescence या बबलिंग भी बता सकते हैं. So it's really up to you how you answer it. Both ways it is correct. Okay, we need to zoom it out a little bit that we can see the whole question. There you go.
This reaction can be followed by measuring the concentration of bromine present in the mixture at regular time intervals. The graph shows the change in concentration of bromine against time in a reaction carried out at 20 degrees Celsius. Use the graph to calculate the average rate of reaction at 20 degrees Celsius during the first 600 seconds. State the units of this reaction, rate of reaction. Average rate of reaction units.
Okay, before you go any further, इस diagram में एक छोटी सी mistake है, I'd like to correct it. ये 10 raised to power minus 5 है, ये multiplied by 10 raised to power minus 5 है, plus 5 नहीं हो सकता. We can't dissolve so much of bromine into water. Not even possible. Okay. So correct the units and you can do the calculation after.
Four, 8, 12, 100 into 10 raised to power minus 5 minus 12 into 10 raised to power minus 5 divided by 600. 1.47 into 10 raised to power minus 6.
Perfect. And units?
Units mole per decimeter cube per second.
Right, good. I don't know what the
Sir,
exact answer is, but since you were doing it out loud, I do understand 100 into 10 raised to power minus 5 minus 12 into 10 raised to power minus 5 divided by 600. So if that has been calculated correctly, the answer should be right. Okay, Jisal, you were saying?
so can you tell the answer again?
I was saying that we need to find average rate of reaction, and since this is what you start off at 0,
Yes.
and at 600 we have this. If I extrapolate, this comes at this point, and this point is actually 12. So we go
So
with.
I am getting 1.47 into 10 raised to power minus 6.
I guess that is right. If you are calculating it like this, and I am going to specifically mention it, अगर आप ये exactly, sorry, my bad, exactly इस तरह से calculate कर रहे हैं, then you must be right.
Yes, sir. I did the same.
So whatever your answer is, if you have calculated it correctly, you must be right. And I guess आप दोनों same answer बता रहे हैं because you both are telling me 1.47. And the units are mole per decimeter cube per second. As Laiba just said, right? So I hope you have the same answers and same unit. Okay, moving on. We still need the graph, so there you go. It's a little bit at the bottom, but I hope you can read part 2.
The experiment is repeated at a temperature of 40 degrees Celsius. This relatively small increase in temperature produces a large increase in reaction rate. Sketch a graph on the same axis to show the expected results when repeating the experiment at 40 degrees Celsius. Sketch a graph on this to show the expected results when repeating the experiment at 40. First, it was at 20. Now they're repeating at 40. Okay. A steeper curve, but it would end on the same axis.
So like this.
Right. Yeah,
Yes,
like
okay.
this, but notice that it has to start at the same point, it has to end at the same point. It should just be a little bit steeper. Steeper means closer to y, closer to x, but ends and starts at the same. Closer to y, we can't really say closer to x, right? I hope you get
Yes,
the
sir.
point. So if you
Yes.
start and at the same points, and if it's a steeper curve, you're correct. Okay, moving on. Part 3.
The rate of reaction increases when the frequency of successful collisions between reactant particles increases. Explain why an increase in temperature produces this effect.
Although this
Rate of
is not
reaction
exactly chapter number this is like chapter number 8 or 9 question, but is connected.
when the rate of when we increase the temperature, the
So the
particles gain more
average kinetic energy of molecules increases, so more number of successful collisions results in more, I guess, rate of reaction.
That will get you 1 mark. What about the second?
So it lowers the activation energy.
No, it doesn't. We're not using catalyst. We're just increasing the
wait.
temperature.
Yes.
more particles gain energy.
Okay,
So
I
more
want you to.
particles gain activation energy equal to or less than, or something like that.
Okay, you are right. You both are right with both of your points now, but I want you to change it a little bit. The way you are answering your answers is good enough for IGCSE, but it's not good enough for A levels. पहला आंसर बिल्कुल सही है टेम्परेचर एवरेज किनेटिक एनर्जी इंक्रीज कर देता है एनर्जी ज़्यादा होगी है पार्टिकल्स की स्पीसीज की मॉलिक्यूल्स की जो भी आप लिखना चाहें दैट इज फाइन सेकेंड वाला जो है जिसमें आप कहते हैं कि मोर नंबर ऑफ पार्टिकल्स आई डोंट वांट यू टू यूज द सेम टर्म एनी मोर आई वांट यू टू स्पेसिफिकली गो विद मोर और ग्रेटर एंड देयर इज अ स्पेसिफिक वर्ड प्रोपोर्शन प्रोपोर्शन का वर्ड आपने जरूर इस्तेमाल करना है ना व्हाई एम आई एम्फसाइजिंग इट ऑन सो मच देखिए ए लेवल में जो आपने नई चीज पढ़ी है जो आपने आईजीसीएसई में नहीं पढ़ी थी वो है बोल्ट्जमैन डिस्ट्रीब्यूशन ग्राफ और बोल्ट्जमैन डिस्ट्रीब्यूशन कर्व ना आफ्टर डूइंग दैट बोल्ट्जमैन डिस्ट्रीब्यूशन कर्व आपको पता होता है कि हम ग्राफ के अंदर एक छोटा सा पोर्शन बताते हैं कि वो पार्टिकल्स का होता है जिनके पास एक्टिवेशन एनर्जी से इक्वल या ग्रेटर एनर्जी होती है और जब हम बताते हैं कि आप टेम्परेचर बढ़ा देते हैं तो फिर ज्यादा के पास एक्चुअली ऊपर एक और कर्व बन जाता है ज्यादा के पास आ जाती है वो एनर्जी तो मोर या ग्रेटर प्रोपोर्शन का वर्ड जरूर यूज करना है because proportion is something that tells us not all molecules have the same kind of energy and not all of them jump over the barrier of activation energy uh, some proportion or some part of those molecules do so if you still stick to the number of molecules term you're not correct if you're defining them in proportion based upon 3 or 4 different bifurcations of molecules, only then you're correct because you're talking in terms of what Boltzmann said for the distribution curve. ठीक है तो proportion का word जरूर इस्तेमाल करना है इसे skip नहीं करना lately कैम्ब्रिज इस पर बहुत emphasize कर रही है अगर आप 2019 के बाद देखें ना तो वो proportion हर आंसर के अंदर कोट करते हैं तो अगर कैम्ब्रिज अपना तरीका चेंज कर रहा होता है किसी चीज के बारे में तो वी आस्क और एम्फसाइज द स्टूडेंट्स टू गो विद द सेम मेथड टू ठीक है आई गेस डायग्राम आप लोग बहुत इजीली कर लेंगे सो आई एम नॉट गोना गो विद द होल डायग्राम बट आई डू हैव वन क्वेश्चन एक छोटा सा क्वेश्चन करते हैं ताकि मुझे ये आइडिया तो ये जो ऑक्सीजन आप ऊपर देख रहे हैं पूरी डायग्राम सॉल्व ना करें जस्ट टेल मी हाउ मेनी लोन पेयर्स शुड बी देयर इन दिस ऑक्सीजन
2 pairs of lone pairs, like 4 in total.
4 electrons in total and 2 pairs of lone pairs. Perfect. Because they are going to form a double bond over here. So whichever one you're using, probably a lone pair over here and over here would do the trick. Good. That is correct. Right? So let's move ahead. I guess दोनों आ गया होगा समझ. So number 3.
The elements in group 17 are known as halogens. Between the molecules of group 17 elements, van der Waals forces exist. State the trend in the relative strength of van der Waals forces down the group 17. Trend in relative van der Waals forces down group 17. Since the reactivity decreases down the group. And ID forces, the atomic number increases. Increases.
Good.
I think.
Now let's discuss the reason. Although the reason has not been asked in the question, but I want it for myself. Yes, the relative strength of van der Waals increases, forces increase down the group in group 17. Why? There are 2 reasons mentioned in the book.
Can we discuss the melting point and thermal stability?
No, you can't. That's not the reason. That's not the cause. That's the effect. I'm not asking about the effect. I'm asking about the cause.
Atomic radii increases. Shielding effect increases.
The shielding effect is not the point. Atomic radii is a little out of line, not too connected. Okay. Remember, there are 2 reasons behind it. The first and foremost reason is the electron shell. How many electrons are there? Okay. Since chlorine में कम electron shells filled होते हैं, chlorine में से ज़्यादा, bromine higher, the iodine even have more number of electron shells filled with electrons. So when the number of electrons increase, the strength of van der Waals forces increases. Now, number of electrons actually increase the ID forces. So stronger ID forces as you go down the group. So we quote 2 reasons. Actually, those reasons are interconnected, but we put them separately. Number of electrons down the group, all right. Number of electrons of filled electron shells means the same thing, and stronger ID forces down the group. Okay.
Yes.
Okay. Part 2. This is easy.
State the physical state of each of the halogens under room temperature. Chlorine is a gas, bromine is a liquid, and iodine is a solid.
Good. Part B.
Liquid, solid. A solution of aqueous bromide ions is added to separate samples of chlorine and iodine. Describe what is observed in each reaction. Explain the answer in terms of the relative reactivity of these elements as oxidizing agents. Oxidizing agents decreases down the group. So iodine is the strongest oxidizing agent, and chlorine is
Sir,
relatively
iodine is the strongest reducing agent, not the oxidizing agent. Weakest oxidizing agent.
Yeah, weakest oxidizing agent.
But that's the explanation. What about the observations?
Describe what is observed in each reaction.
So observation in addition to Cl2, ये बता दिया
Sir,
आपने?
chlorine will be, if there is a compound, so chlorine will displace the compound, I guess, or it will gain electron.
Yeah, it does.
Green
But
gas.
observation, green gas to what?
Yes, green gas.
To
Because you need to tell the before and the after observation. Green gas before observation है, after क्या होगा? साथ already बता चुका हुआ displacement हो जाएगा. So
orange brown.
Orange brown, good. Iodine के साथ क्या observation आएगा?
Gas. Orange. Iodine
Sir,
के
there will
साथ
only be, sir, there will only be, sir, there will only be, what you call, purple papers. I guess no brown because it won't be able to displace.
Actually, there is no visible change. ठीक है ना? आइडीन हम यूज
Yes.
करते हैं एक्वस में डार्क ग्रे सॉलिड के तौर पे, तो हमारे पास फूड इस तरह से evaporate या sublime होता ही नहीं है कि purple vapors बने. No visible change because no reaction is going to happen. Iodine
Oh,
cannot
okay.
displace bromine. ठीक है? And you've already told me explanatory part for it that chlorine is stronger oxidizing agent, so it would be capable of displacing it, but iodine is a weaker one, so it won't displace. दोनों लिखिएगा, आपने दोनों लिखने हैं, ठीक है? So
Yes, sir.
consider it as 4 points, one for addition observation in chlorine, one for observation in iodine, and explanation, one for chlorine and one for iodine. That's all for 4 points, 3 marks. Okay. लीच की क्वेश्चन. अब ये रटी रटाई इक्वेशन है, ये याद कर लें, ये सच ही बार बार आती है. One is with cold dilute NaOH, one is with hot concentrated NaOH. ठीक है? This one is for cold dilute NaOH.
Yes. The products would be NaCl plus NaClO plus H2O.
Good. Okay, let's move on to part D. One.
Find the tertiary base.
The conjugate
Base. Acid is
acids. Oh no, base. So say proton.
proton acceptor.
Proton
acceptors.
acceptor. Right. Proton acceptor या H positive acceptor, जो भी लिखना चाहें, both are correct. And do not discuss any conjugates because they're not talking about products. ठीक? Ionic question.
Ionic equation for the reaction between ClO and H2O.
ClO negative.
ClO negative.
Now this is not a part of the book. अब ये वो आपसे खुद लिखवा रहा है, सो अपनी अकल से सोच के जो बना सकते हो.
Reaction between Cl negative plus O negative H2 plus O negative O cancel हो जाएगा, Cl and H के दरमियान बनेगी. So
Don't forget, part D में जो लाइन लिखी हुई है वो आपको इस इक्वेशन को कंप्लीट करने में हेल्प कर सकती है. When Cl negative is added to water, it behaves as a frosted lowry base. ये लाइन इस क्वेश्चन का आंसर करने में हेल्प करेगी, वरना आपके पास एक्चुअली में बुक में कुछ पढ़ाया नहीं हुआ कि रिएक्शन को कैसे प्रोसीड होना चाहिए. So this line is the biggest hint you need to follow. Go ahead.
okay. So ClO negative plus H2O gives us HCl as a base. HClO.
Sir, will H3O form? HCO minus.
No. Try and understand the point that ClO negative is a lowry frosted base, and you just said that means it would accept a proton. So water is acting like a acid.
Okay.
ClO negative is a base, and take a proton out of water, add it to HClO negative, and then see what forms. I hope this explains it. So water is acting like an acid because it is going to donate a proton. ClO negative is acting like a base because it is going to accept a proton.
HClO negative plus H2. No. One second.
Sir,
HClO
ClO plus OH minus.
HClO plus OH minus. Perfect. Now, let's clarify a little bit. H2O is made up of H positive and OH negative. जब इधर से इधर H positive जाएगा, Remember, H positive plus ClO negative would form what? Simply HClO. दोनों के charges तो balance हो जाते हैं. What's left out of water would be OH negative. तो ये दो products हैं आपके पास. और ये लाइन हमें बताती है क्या करना है. अब बच्चे दोबारा वापस जाके इस लाइन को नहीं पढ़ते हैं और इसको समझते नहीं कि ये लाइन एक्चुअली में इसलिए लिखी गई थी कि पार्ट 2 आप सॉल्व कर सकें, वरना तो पार्ट 2 कहीं पूरी बुक में दिया ही नहीं हुआ, आपको कैसे पता चलेगा. I hope this explains it. Okay, moving on. Part E. Part E को भी ध्यान से करना है.
The concentration of NaClO in bleach S is xg decimeter cube, grams decimeter cube. NaClO reacts with H2O2 aqueous as shown. A 5 centimeter cube sample of S completely reacts with H2O2. The volume of O2 produced is 24 centimeter cube under room conditions. Assume that only the NaClO in S reacts with H2O2. Calculate X. Show your working. The concentration of NaClO in bleach is X. You have to find the concentration.
Yes, you have to find the concentration. अगर गौर से देखें आंसर में क्वेश्चन की पहली लाइन में you need to find mass concentration. But every
Yes.
piece of information that is given in the question leads to molar concentration, which means ध्यान से समझें, पहले molar concentration find out करें और फिर उसे conversion principle की बेस पे mass concentration में convert करें. This is going to take a little bit of time, so take your time. I'm here.
14.9.
14.9. Since we're talking about 1 decimeter cube, you do not need to divide it by anything, because 14.9 divided by 1 would be equal to 14.9.
Yes, sir.
Make sense?
Yes, sir.
Good. If that makes sense, let's move on. Okay. Part F.
Sodium chloride oxidizes dilute hydrochloric acid to form 3 products. The products which contain chlorine have chlorine species with oxidation number -1 or 0. No other species changes this oxidation number during the reaction. Use the information to complete the ionic equation. 0 है तो Cl2 होगा -1 -1 comes from this one is when chlorine is alone, a chloride ion, Cl negative, and then the last product would be oxidized to form 3 products. H is left and O is left. H2O?
Good. So the negative one is Cl negative, and the 0 is Cl2, and the leftover forms H2O. Now, what kind of balancing numbers would we need? Still need to mention it.
Just 2 HCl.
You can't leave a blank empty. So 1 and 2.
Okay.
That's tricky. You can't leave a blank empty, so you always fill it with 1 in case of balancing numbers.
Yes. Okay, sir.
Okay. So